I think on that, we did pretty good. The average is pretty good for the class. So you guys pretty much understood what you're supposed to do. I still had a few people that would call it things like Lab ONE instead of Lab 1 or Homework 3. So just make sure that you guys are watching what you're supposed to be naming things, because then I have to go through and rename it. And I've got 30 some of you in here, so which is over what we're supposed to have in a class, but oh well. So we did pretty good. Probably the couple things that people didn't pay attention to was spacing. So if you looked at the output, right, you could see that they were all lined up. Some of you did that. Some of you did not, so I took off a couple points if you didn't do that. Otherwise, I think we did pretty good. Are there any questions on that homework or that lab? No questions? So I think like one person that I saw at least solved it in a efficient manner, but we will kind of look at it today here. So you guys probably all got this figured out. All right, getting the input is pretty easy. We figured that out. Also make sure we didn't put a new line on there, because if you looked at the example, that's the way it was. All right, so the general way to solve this, there's actually a couple different ways, but the general way to solve this is to check to see if the number is greater than the digit that you want to print off. If it is, right, we want to do that. So if value is greater than or equal to 128, because that's our first digit. The easy way is to do the else. Some people would do the else if, which is okay, right? But if it's not greater than or equal to 128, then clearly it's less than 128. And we're kind of assuming that input in a negative number, right? Because I didn't give any examples showing a negative number, which is fine. So if it's bigger than 128, then we print off our digit. Let me grab the text for that. Okay, so if it's greater than, we get this 1, right? And if it's less than, then we get a 0. And then what do we do with value? If it's greater than that, the boss is looking at me like, what the heck? What do you think we do with it? You didn't do anything, right? Yeah, we need to subtract 128, because remember when we did it in class, right? If I write the number 200, right, then I need to subtract 128, and then I get the number, let's see, 72. Is that right? I did my math right. All right, so my result just went down, so now I have the number 72, which I need to figure out what the bits for that are, right? So here we can say value is equal to value minus 128. And then we repeat this how many times? Repeat it 8 times, right? Well, I don't like repeating things, right? You repeat yourself when you're coding, or you end up with lots of problems. So, if there was only a way I could just take all this stuff and I could just put it together in this prepackaged thing that I could just use over and over again. If only was there some way I could do that. Oh, what was that concept that I learned? Anybody want to take a guess? Oh, a method. Yeah, we could write a method, right? So we could take all this code that we just got done writing, and we could say, when I do this for 64, all of this stuff is the same except everywhere I have the number 128, I need to turn it into a 64. So public static. What type should I return for this method? What am I changing? I'm changing an integer, right? Because I'm going to change value, right? So I want an int. I'll just call it print digits. Awesome. And what kind of argument should I pass into it? What is the thing that changes every single time? The value, right? Okay. So we're still missing stuff, but well, maybe I don't want to. So I got value, which is the number that I'm subtracting from, but I also have something else, right? I have maybe the digit that I'm comparing it to, right? So in this example, it's 128. So then everywhere I see 128, I need to do digit. Okay, we had value from originally. Anything else I need to do? What else do I need to fix? My print statement, you're right. So maybe instead of print line, we need to do, anybody know how to format a digit to 3 places with spaces? I'm thinking it's %3D. We'll see. So then I need to replace that with digit, right? And then this is a 0. And what's it going to complain about? So a method must return the result of type int. What am I going to return in this method? What did I modify? Value. All right, so let's try it. Let's see if it works. So how do I call this function? Speak up. Print digits. Yeah. And what are my arguments that I pass it? What's the first thing need to be? Well, I don't need to say int value. It is an int. Right, so when I'm passing an argument in, I don't need to say its type because I've already declared it. So I just put value. And then what's the second thing that I need to put in? What digit am I testing against? 128, right? So let's see what this does. Okay. Let's run it again. All right. So we got one of them. Now what do we need to do?
I put your first part in an if statement, and then have it so that it repeats that until you get to 0. So your value is 0.
Okay, you're jumping the shark here a little bit, but, right? We're not going to put it in a loop yet.
I see it.
Why do we need to put it in an if, right? If only we had this repetition thing that's covered in the chapter that we haven't talked about that you're supposed to read. Yes, we'll eventually get to that, right? So, here then I can try my 64. So let's do 250. Oh, I forgot my new line. All right. Put our new line in here. Try it again. And now, instead of copying and pasting, how many lines? 20 to 28. 8 lines of code, right? I got 1 line. If only there was a way where we'll learn about that. 8, 4, 2. Well, that's not right. Because everything's a 1. What did we do wrong? Okay, so there's a problem with our program. So one of the things that when you get into my upper level classes, you're going to say, Dr. Miller, I got this problem. My program won't work. And the very first thing I'll say is, did you debug it? And you're like, huh? I would say, well, remember in 130 when we learned how to debug. So here, 130, we're going to learn how to debug. All right. So we have some problem with our program, and we don't understand what the problem is. So all of the different IDEs tend to have these abilities for you to basically stop your program and look at what is happening at any point in time. And I'm using Eclipse, but I'm pretty sure IntelliJ works similarly. So in Eclipse, I just double click on a line, and you see it puts this little dot there. That means that when I run my program, if I debug it instead of just running it normal, it will stop at that line, and it'll show me all kinds of information. Like, all right, let's try this. So let's debug our program. So in Eclipse, you hit the little bug. Funny story about bugs, right? So originally, when you had these computers that were built out of vacuum tubes, they would take up rooms and rooms and rooms. And when you have a vacuum tube, it tends to warm up, right? So it creates heat, which apparently bugs like. Right? So there would be bugs crawling all over it. A bug would get across 2 connectors, right, short out, so you'd have to go and find the actual physical bug and take it out, right? And then possibly it would blow the vacuum tube, possibly not, so you might have to fix it, right? So you were debugging, right? You're taking out these bugs, right? So that's why we call them bugs inside of programs. So when you're debugging, you are going through and finding bugs or problems. So here, I think this is pretty much the default setting. So if you look on the right-hand side, you can see that it says variables. So it'll show me all of the variables for my program. Well, I don't have any variables. Let's do a couple steps here. At the top, you can see there are a bunch of buttons. There's the play button, which will run your program. It'll run it until it hits what's called breakpoint. So this little blue thing on the side is called a breakpoint. We have the stop button, which, as it implies, stops your program. We have a couple of buttons. We have step into. So step into will jump into a function. Right? So if you have a function, it'll go into that and start executing. So we'll jump into our function here in a little bit. But I don't want to jump into the function nextant because I do not care how that works. Right? Does not concern me the least. It does stuff, right? That's all I really care. So I'm going to step over that. right? So it'll jump over that. Now it's down here, right? So we had our print on line 11, and then we are getting our next integer on line 12. So it's basically waiting for me to type a number. 250. All right. So it did that call, right, to that function, came back. Now I'm on line 13. And now I'd like to see, okay, what's happening inside of this function called print digits on line 13. So I can go ahead and hit step into. So one of the things that you'll see is up here, this is called our stack trace. So as our program is executing, it keeps track of where it was, right, and where it is. Right? So it has information about, oh, well, technically we're on binary.main, line 13, and then that called print digits, and in that function we're on line 26, right? So we can go through every single step. All right, so if we look over here, we can see that we have two different numbers, right? We have value, which is 250. We have digit, which is 128. When you're in here, you can actually hover over them, right? And it'll show you what those are. So value is 250, digit 128. If value is greater than, right? So I can use my step over functions to say, okay, let's do this, right? So we printed our digit, right? Value is 250. That is clearly bigger than 128. Okay, so it prints off our digit. That's a 1. Value is still 250. Digit's 128. If I step over that function, now we can see that value is now 122. All right? We can step over that line. Okay, we're going to return value. Right? So we have executed that function, right? Well, value is still 250. But what did we forget to do?
Subtract the 128.
Well, it subtracted it in the function, but we didn't overwrite our value with the value in the function. How could we do that? Anybody want to guess? What is print digits returning? Okay, I answered 250. What number is print digits returning? What was the number in my middle of my function? What was it? Like what, 122? So it's returning me 122, but in my next one I'm comparing again to 250. So what do I need to change in my program? What number should I pass to print digits value 64? What number should I, like the actual number? 122, but I'm passing 250. Okay, 250 is in which variable? Okay, so I need to change to 122, and where's 122? The result of, okay, true. I can assign value the result of the function, right? Because remember when I called print digits, it just gives it a copy of value. Remember we talked about that. So it has a copy of the number 250. So if I want to update value, I can say value is equal to the result of that function. So now when I debug it, let's debug it again. I'll just step over the function. So value went from 250, right? I assigned it the result of calling that function. Kind of like I declared a variable called value and I assigned it the result of the function nextInt. NextInt did magic, right? Voila! We have a number. Right? It did magic. I don't care how it works, but it works. Right? But we wrote print digits and we said, oh, print digits is going to go ahead and print off if we have a 1, and then it's going to update that copy of value, and then it'll return to us that copy of value. And now we can assign it to our original value. Now maybe I was negligent. Maybe I should have called this V, right? So we wouldn't get the things confused. Right? Because a lot of people will confuse it, right? I had value named in both spots. Well, why wasn't it updating? Well, it was a copy. Right? And right, if I give a copy of a newspaper to you and you change it and put evil horns on Donald Trump, right? That doesn't change what comes out of the hub, right? It's still the same thing. So all we were missing was one little line here where we just updated value with the result of our function. And I probably don't need it for the last one, right? Because we're done. So let's try it. Let's see what this does. 250. I don't know, is that right? Maybe. I'm an efficient programmer. But I'm not very good at spelling, but base 10, 250. All right, so we got what, 4 ones, and then 10, 10. What would that be in hex? What are 4 ones? F. 10, 10. A. Let's see, are we right? Woo. You know, I'm pretty sure you guys can learn hex because I taught my 8-year-old baseball kids how to count to 16 using hex when we were stretching. So you guys can do it. I know you can. My 8-year-old can. So, all right, any questions? No questions. Okay, so I did, right? We have talked about, I can't remember what chapter we're. Methods is chapter what? 5? Okay. So chapter 4 is going to talk about loops, right? So we have this ability to do things over and over again. So when we get more in depth into loops, we're going to talk about how we can take this program and go from, well, right now it's about 38 lines long. All right, we're going to compact everything, and we'll probably get it to, now we'll get rid of some of these lines, right, in here that are in the middle. And technically we could, right? People who care about lines would maybe like remove these brackets because they don't like them, but I like putting them in there to be very clear on exactly what's happening. And I think, yeah, we could collapse other things, but we won't do that. So this is kind of a solution to the problem if you do it with the methods. If you did it normally, right, you would have all these lines repeated, right, over and over and over again, right, one for each one of those that we had.
If we use a method, how about like the number after digit? Because it outputs like digit 7, digit 6, digit 5 or something.
Digit 7, digit 6. Oh, you're right. We printed off digit 7 for all of these. Oh, I messed up. I forgot. All right, so let's fix that. So we're printing the digit number here is exactly the same for all of these, so we missed that one. So we can turn that into a number. And so what do we have to do in order to pass in the right digit number for this? I think there's 2 ways we could do it. I'll do it the easy way first.
You can put a byte
I'll go ahead and use int, that's fine. And like, what are we gonna call it? I'll call it offset. That's a nice word.
And then you add up offset in front of
Yeah. And now all my function calls are gonna be, go ahead and terminate that.
and then in the print digits, you add in the
Off est. As you can see. All right, so we could add this in here, right? So this is 7. I'm gonna show another way, hopefully, if I can do it right. Let's make another version of this. Okay, so what is, we got, let's say we had 128. That's equal to 2 to the what?
power 7.
Power of 7. Okay. So is there any mathematical function that we could operate on 128 to give us the number 7? There's only a mathematical function that would tell us what the power is. Logarithm! You're right. Alright, so if we do the log of 128, we'll get the right answer. Alright, so if we do log of that number, it's going to use base e. What base do we actually care about?
It needs to be base 2.
It needs to be base 2. Well, funny thing. So, right, logarithm basically is what is the power you have to raise a number to get another number. So, exponentiation and logarithms are basically inverses, right? So if you do an exponent, the log base 2 of 128 is equal to 7. But if we want to convert a number from one base into another, basically I can do the log of 128, and if we just do normal log, you see it's got log 10. If I want to convert that to a different base, all I got to do is divide by that base. And then I get the right result. So I can use either log e or log 10. I'll use log 10 because that tends to make more sense. And I can divide that by, I'll just type it. All right, now, anybody want to guess why it's complaining? Why do I have the, oh, well, I need that, but that's not why it's complaining. I do need that, you are correct. You're right. If I hover over it, it's going to tell me. Mismatch cannot convert from double to int, so I tell it, you don't know what you're talking about, computer. I'm going to go ahead and turn this into an int. Yeah, put parentheses around it. All right, let's see if this works. So I'm actually going to put a breakpoint in here. I'll go ahead and debug it. And we'll see what it does. All right, so we're checking the number 64. Hey, magic, right? I got the number 6. Right, so it's actually 2 to the 6. Okay, and I'm going to remove my breakpoint. Just hit play, see if it works. All right. All right, looks like the right number. Okay, so we did it right. So I guess we learned a lot here, right? We learned about logarithms, and you're like, hey, when am I ever going to use logarithms? Does anybody know what they used to use logarithms for a lot? There's this really old invention called the slide rule. So a slide rule is, they have this, there's an interesting property of logarithms. So if you take the log of one number and you add it to the log of another number, that's actually multiplying those two numbers together. So if I want to take 200 times 7, I can take the log of 200 and add it to the log of 7, and the result would, if you do it on the slide rule, the result would be 200 times 7. Right? So before they had computers, which could very easily do really large math, they would have, and before calculators, right, they used these slide rules. And so basically you'd slide it to one part and then you'd slide it farther, right, to multiply it, and then you'd look on the table and it would show you, okay, this number is, you know, what did I say, 200 times 7, right, this is 1400, right? So you would have this ruler that would have all of these, let me see if the picture shows, you can see. Right, so they would have all these markings, and then you basically slide it to do the addition, right? And then you would look at the result on one of the bases to do it, right? So that's what a slide rule was, and it operates on logarithms. All right, and in computer science, we end up using logarithms a lot because we have things, right? We have this number system that grows by powers of 2. Right, and so log base 2 is very useful in figuring out lots of things. For example, right, we use it to talk about sizes of things. Right, so if you talk about a kilobyte, anybody know how many bytes are in a kilobyte? 1024, but why is it 1024 and not 1,000? It's 2 to the power of 10, which is equal to 1,024. And then you've used your answer, so now you can't talk anymore. Right? So that's a kilo. What about a mega? It's a kilo. So it's 2 to the what? What'd you say? 100. No, you're going a little too fast. This many, so it's 2 to the 20. Right? So it's 1,024 times 1,024, which is 10485. I don't remember that one very off the top of my head. And then a giga is 2 to the 10, 20. Am I doubling or am I adding? Oh, 30. All right, so if you buy, and you have to look at your hard drives, right, but there used to be this problem about manufacturers would define a hard drive size in terms of 1 gig, a byte, is equal to 1 billion bytes. But your computer would think that you need 1,073,741,824 bytes to equal a gigabyte. So you'd plug it in. It would start off as 100 gigabytes. You'd look at it, and it's like 95. You're like, what's wrong, right? So there's a whole bunch of people suing because manufacturers would say it one way, and then computers would read it a different way. Right, and so we use, right, these logarithms, right? And when we talked about 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 20, 48, 40, 96. right? Those are all powers of 2, right? And those are the common ones that we use, and the common ones that you'll end up knowing after you spend enough time learning about numbers. All right, so any questions? I know I threw math at you, and math is hard. We don't like math, unless we're math majors. Right? And I overloaded my methods here, right? So the first one I called, and I actually put the number 7 in, and I used our original way to do it, right? The second one, right, we just used math to figure out, well, I know if it's 128, that's really 2 to the 7, and I could actually use logarithms in order to figure out that, because it's very, very easy to figure out. Okay, any questions on that? Yo? All right, so I hope to put together an assignment. I think it'll be due next week because I don't think we have enough time to do it this week. Right, but on Wednesday we're going to start talking about loops. Right, so we've talked about methods. I don't know if I need to beat that dead horse anymore, but I think we're done with that. So we're going to start talking about loops and how we can do these things over and over again very simply. So we'll start off basic, but then eventually we're going to come back to this program where we're going to rewrite it so it's even easier. All right? See you guys Wednesday.